Hello and welcome to the code overview for Pistol Whip PC. To start, I'd like to do a quick introduction of all of the team members so you know who's who.
Hi, I'm Josephine.
Hello, my name is Nazifa.
Hey, I'm Donovan.
Hi, my name is Josh.
And my name is Isaac. Now with the formalities out of the way, let's jump right into the code.
When setting up the camera, there is a default zoom. The camera focuses on the player but follows with the offset that keeps the player to the left of the screen. We set up a basic player and added animation using the sprite sheet and JSON creator. The player's gravity scale is set to 40 times in the regular gravity to make the jumping easier to use.
Make static barrier is a function that was used to create two barriers set at the bottom and the top of the window that do not move. These barriers interact with player and enemy bullets, despawning them on contact. Make moving barrier is a function that is similar to make static barrier, as it creates a barrier on the right side of the screen that moves at the same speed as the player. It also only despawns player bullets, as interacting with enemy bullets would make it so that the enemies could not shoot. Make moving back barrier is a function similar to make moving barrier that creates a barrier on the left-hand side of the screen. It can despawn both enemy and player bullets, as it follows at the same speed of the player. This entity is stored in a variable, as to know when platforms and enemies pass off of the screen. Make image is responsible for creating all non-interactable graphics such as the background and the control layout, by simply displaying a sprite on the screen. This block of code is used to create the main platform for the game. It stretches the length of the game and only interacts with the player and enemies.
This for loop will create 5 platforms, enemies, hostile bullets, and shot triggers. The positions of these entities are determined by the coordinates stored in row I of this position array. Platforms use these x and y coordinates directly, while enemies, hostile bullets, and shot triggers use specific offsets. Each of these entity types are stored in separate vector lists at index I.
The make enemy function creates the enemies and adds them in the enemies vector so that they may be reused throughout the game. The make hostile bullets function creates the bullets and adds them to the hostile bullets array. These are set to transparent and will only be seen when fired. The make shot trigger function creates the triggers that the player enters to make the enemy shoot. The position of these triggers are 120 units left of the enemy that shoots when the trigger is activated.
This for loop creates the 5 entities that will be turned into the player's bullets, and stores each one in the bullet hold vector list before calling the make bullet function. Make bullet attaches the necessary components to the bullet entity stored in bullet hold at index. These components are similar to those attached to enemy bullets, but with a few key changes. First, the position of every bullet is set to be placed high above the visible game area. Second, the bullets are set to enum type bullet. Finally, they are set to collide with enemies and boundaries. This for loop will iterate through the enemy's vector list and check the ready variable of every enemy. If an enemy at index I has the variable set to true, ready is set to false, and then the enemy is moved off screen along with the entity located at index I of the shot triggers vector list. If the entity located at index I of the hostile bullet list has a velocity of 0, it is also moved off screen. Any remaining hostile bullets that have made contact with the player are set to be completely transparent. This for loop will iterate through the platform's vector list and will check to see if the platform at position I is now behind the screen. If it is, the game will check to see how many times a platform has been assigned a position, which is stored in spawn count. If the value of spawn count is less than that of the total number of platform coordinates saved, the platform will be assigned the position stored in row spawn count of the position array. The enemy, hostile bullet, and shot trigger at index I of their respective vector lists are also relocated using the same offsets mentioned previously. Spawn count is then increased by 1. If there are no new positions left to assign a platform to, its entity and physics body are deleted, along with those of the enemy, hostile bullet, and shot trigger located at index I of their respective vector lists. If the active bullets vector contains at least one bullet, it is iterated through and checks whether the bullet stored at index I has been set to be not in use. If this is the case, the bullet's velocity is set to 0 and it is moved off of the screen. The bullet is then removed from the active bullets vector and pushed into bullet hold.
In the game, the mouse is used for aiming. We do this by first locating the mouse's coordinates within the window, converting those into the actual game space, then using those coordinates to actually find where the player is trying to aim. In order to shoot, the player must click the left mouse button. Before the shot actually fires, we double check and update our aiming function to make sure it is exactly where they wanted, and then call the fire bullet function to actually make the shot appear. Fire bullet takes an inactive player bullet and fires it towards the gathered mouse coordinates. If there are no inactive bullets currently available, it will take the oldest most active bullet and update its values to be a newly crafted bullet, only allowing for 5 bullets on screen at a time. Because the game is designed around very quick and accurate aiming and shooting, this is the time where we decided that gamepad implementation would simply not be very fun to use, so we decided to not include it.
Jumping in Pistol Whip PC was accomplished through collision detection with the floor to prevent infinite jumping. We used the Physics Playground listener, as well as a check of the player's height, as the Physics Playground listener had some inconsistencies. In regards to how we handled velocity of the jumps, we have a variable initial player velocity, which we implemented using a timer set so that if the spacebar is held for up to 0.4 seconds, velocity is added to the player every frame. This allows for slight variation in jump height, which is accomplished by the player by holding the jump button for different amounts of time.
The Physics Playground listener is also responsible for keeping track of other types of collisions, most notably bullets. Player shots interacting with enemies will increase the overall score, while enemy shots interacting with the player will decrease that score. And if any of the bullets interact with the edges of the screen, the bullets will be removed from the player's field of view.
As soon as the game starts, the player's velocity is immediately set to 70 units to the right, which remains a constant x velocity for the player until they reach the end of the level, at which point their velocity is immediately set to 0. The game does not immediately start with the scene, nor does the music for the level. There are clear instructions to press enter, which is our key to start both the game and the music once the player is ready.
That's all we have for you in our Pistol Whip PC code overview video. We hope you enjoyed watching, and we'll hope you enjoy playing the game too.